Hi there, Professor Barber here. This lesson is titled Dividing Polynomials. We begin this lesson by reviewing arithmetic long division. The purpose is to refresh upon the process so that we can learn how to perform polynomial long division in a similar manner. In keeping with the goal to develop the necessary knowledge and skills to solve polynomial functions of any degree, we add synthetic division and the remainder and factor theorems to a repertoire of skills for this purpose. To that end, upon successful completion of this lesson, you will 1. Be able to perform long division of polynomials. 2. Be able to determine when synthetic division is appropriate and perform it. 3. Be able to apply the remainder theorem. 4. Be able to apply the factor theorem. And 5. Be able to apply the concepts and skills of this lesson to factor polynomials. Find the quotient by long division 739,426 divided by 25. Remember learning long division in grade school and perhaps even thinking then that the skill is obsolete? After all, we have calculators for that. Guess what? Engineers and computer scientists write the code and build the technology for such tools. That necessarily means you, as a future STEM professional, must know how to accurately and efficiently perform basic arithmetic, among other skills. With that in mind, let's revisit and refresh on those long division skills. Okay? We set up long division by writing the divisor first, then writing the symbol, a straight line next to the 25, then a horizontal line going across hopefully the length or the width of your dividend number. The dividend is 7, 3, 9, 4, 2, 6. Okay, so I went a little bit longer than I needed to. The process is we line up by place value and recognize that 25 does not divide into 7, but it could into the 7, 3 double digit. And so 25 times 2 is 50. We write 50, lining it up under the 7 and 3, and remember you subtract. So 73 minus 50 is 23, and we just drop down the 9. And so the next question is, what is the maximum number of times 25 will go into 239? I get that to be 9, because that's $2.25, right? 9 quarters. So I will subtract 225. And let's subtract. So the difference of 239 and 225 is, here's 14, and let's drop down the 4. So 144, how many quarters will go into 144? That turns out to be 5. And so 5 times 25 is 125, $1.25. Let's subtract that. And that difference is, I have to borrow. That's okay, I think I could do that. 14 minus 5 is 9. Good. And then the 4 becomes 3, so 3 minus 2 is 1. Bring down the 2. 192. How many times does 25 go into 192? It turns out to be 7. And if you have 7 quarters, you have $1.75. So let's subtract that from 192, and that difference is 17. Let's bring down the last number we have, that's 6, and we'll do 7. That's the number of times 25 will go into 176. That turns out to be 175. That's 7 times 25, so the difference is 1. So now you know how to do long division, or we refreshed on how to do long division. Let's name these parts. The number that you divide is called the dividend, okay? The number that you divide with is called a divisor. The answer of long division is your quotient, QUO. T-I-E-N-T. Any remaining number after you perform the last thing that you can is called your remainder. We have a formal setup for how to express such answers, and it is called the division algorithm. And we would write this as 739,426 is equal to 25 times the quotient, which was 29,577, plus the remainder. The setup is the dividend is equal to the divisor times the quotient plus the remainder.
Roman numeral 1, the division algorithm. Let's begin with the definition. The division algorithm. If p of x and d of x are polynomials, with d of x not equal to 0, then there exist unique polynomials q of x and r of x, where r of x is either 0 or of degree less than the degree of d of x, such that p of x is equal to d of x times q of x plus r of x, where p of x is called the dividend, d of x is called the divisor, q of x is called the quotient, and r of x is called the remainder.
Divide 15x cubed minus 14x squared plus 3x minus 4 by 3x minus 4. Let's set up this polynomial long division as we would arithmetic long division. I'll write the 3x minus 4, that's the divisor, and then next to it write the dividend, 15x cubed minus 14x squared plus 3x minus 4, and the division notation. Now, to find the terms, we need to line up just as you would do place values. The divisor has a power of x to the 1. The highest degree term is x cubed. So in lining this up, we'll go 2 spaces over and write x squared as the degree term of the quotient, and 3 times what gives you 15? 5. Okay. So now we'll multiply each term of the divisor with the 5x squared. So 5x squared times 3x will give you 15, 5x cubed, and then 5x squared times negative 4 gives you minus 20x squared. Remember, as in doing arithmetic long division, we subtract. 15x cubed minus 15x cubed give us the desired 0. Now, you're going to have negative 14x squared minus negative. That means you add the 20x squared. So that negative 14 plus 20 is 6. Don't forget the x squared. Bring down the 3x. What times 3x will give you x squared? You need one more x, and you need a factor of 2. So 2x times 3x is the desired 6x squared. 2x times negative 4 is negative 8x. And again, remember to subtract. 6x squared minus 6x squared gets rid of that term. That's what we needed. Now, 3x minus negative means add. 3x plus 8x is 11x, and then bring down the 4. And the last one is, what factor do you multiply to 3 to get 11? And that turns out to be the fraction 11 thirds. So 11 thirds times 3x gives you the desired 11x. and then 11/3 times -4 is negative multiplying across 44/3. And remember, we have to subtract this anyway, so let's subtract. 11x minus 11x is 0. Now you have to perform, and if you need to, go to the side and write -4 minus negative, so that's add 44/3. You need a common denominator, so that's -12/3 plus 44/3, and that's equal to 32/3. And so express your answer. Your quotient is the polynomial 5x squared plus 2x plus 11/3, and you have a remainder, that's the number or whatever is remaining, of 32/3. Divide g of t equals 4t to the 4th minus 2t cubed minus 70 times t squared plus 59 times t minus 12 by the divisor 2t squared plus 8t minus 3. Let's set this up. We'll write the divisor 2t squared, come on, squared, plus 8t minus 3, and next to that let's write 4t to the 4th minus 2t cubed minus 70t squared plus 59 times t minus 12, and we'll put the divisor. And now we're ready to begin. Let's note that the divisor consists of 3 terms starting at t squared. So when we line this up with the dividend, we go 3 places
the remainder
in, and
theorem
let's line it up with
and
the
the factor
70t
theorem.
squared.
The factor theorem
we need to get rid of
states
the 4t
C
to the 4th.
is a 0
So
of p
what factor
if
can
and
you
only
multiply
if
to the
x
2t
minus
squared
c is
to
a
get 4t to the 4th?
factor of p of x.
We need a t squared
Divide p of x
and a 2.
equals x
So
cubed
let's multiply
plus 2x
each
squared
term of the
minus
divisor
3x minus
with
10
2t squared
by
2t
x
squared
minus 2.
times 2t squared
The factor theorem lets us
is
compute
4t
p
to
of
the
2,
4th,
which
2t
means we will
squared
replace
times
every x in the
8t
polynomial
is
with 2.
going to be plus
That will
2
give
times
us
8 is 16, and then
2
t cubed,
plus
and 2t
2
squared times
2
negative
squared
3 is minus 6
3 times 2
t squared.
minus
We need
10.
to subtract the
Let's do the
entirety
arithmetic.
of this
2
3-term
cubed
polynomial.
is
So
8.
4t squared
2
minus
times
4t
2
squared
squared,
is the
that's
desired
also
0. We've got
plus
negative
8.
2t cubed
Negative 3 times
minus
2
16t cubed.
is
So
negative 6,
2
and
minus
we
16
still have
is minus
minus
18
10. Let's perform that
t
arithmetic.
cubed.
8
And
plus
then
8
negative
is
70t
16.
squared minus
16
negative
minus
means plus.
6
So negative
is 10.
70 plus
And 10
6
minus negative
is
10
a whopping minus
gives us
64, and let's remember the
0.
t squared. We bring
Let's get
down
some
the
terms straight.
59t. So what factor
X minus
needs
2
to be
is
multiplied
called
to
a
the
factor.
2t squared of the
2 is a
divisor
0.
to get
It
negative
is also
18t
called a
cubed?
root.
We
and
need
the
a
ordered
numerical
pair
factor of
2
negative
comma
9
0 is
and
an
a
x
variable factor
intercept.
of t. So negative 9t times 2t squared is negative 18t cubed. Negative 9t times 8t is going to be negative 72, and t times t is t squared. And negative 9t times 3, negative and negative, will give us a positive 27t. And again, we need to subtract. Now let's perform that subtraction. Negative 18t cubed minus negative 18t cubed, adding those together is 0. Negative 64t squared minus negative 72t squared, that's actually adding the 72. So negative 64 plus 72, that gives us 8t squared. And 59t minus 27t That difference gives us a positive 32t. Now we'll bring down the remaining constant of negative 12. What do you multiply to 2t squared to get 8t squared? 4. Let's distribute that 4 through our divisor. 2t squared times 4, that's 8t squared. 8t times 4, that's 32t. And negative 3 times 4, that's negative 12. Perform that subtraction, and the difference is 0. We found a factor. The quotient is the expression above the division symbol, which is t, which is 2t squared minus 9t plus 4, and because the remainder is 0, our quotient is also a factor. Roman numeral 2, synthetic division. Synthetic division can be used when the divisor is linear. A divisor is linear if it can be expressed in the form ax plus b, where a and b are real numbers. So for example, if you have a divisor that is x plus 7, then in synthetic division you would use x equals negative 7. We are looking for where the divisor equals 0. So for example, if you write x plus 7 equals 0, solving for x will give you that the x equals negative 7. Let's do one more. If you have a divisor that is 4x minus 2, then what you would use is the x value when 4x minus 2 is set equal to 0. That is 4x equals 2, and so x is equal to 1/2. We would use the constant 1/2 here. We would use the constant negative 7 if your divisor is x plus 7. Use synthetic division to divide the two polynomials. Clearly indicate the quotient and remainder. The polynomials are x cubed plus 3x squared minus 8x plus 4 divided by x minus 3. In order to use synthetic division, your divisor must be linear. The divisor for this problem is x minus 3, and we solve for the constant by setting the divisor equal to 0. That tells you that we're going to use the value x equals 3. In order to do synthetic division, this is how we set it up. List the divisor, and then to its right, list the coefficients of the dividend in decreasing order. And so for x cubed, the coefficient is 1. For 3x squared, the coefficient is 3. For minus 8x, the coefficient is negative 8, and the constant of 4. Now, draw a vertical line between the divisor and the coefficients of the dividend, and then draw it all the way horizontally to cover all the way to the end of the dividend. Now, to perform the synthetic division, you start with the leading coefficient and just add down. 1 plus nothing is 1. Multiply that 1 below the line with your divisor value of 3. So 1 times 3, and put it under the next term. And so now you have 3 and 3. Add. So 3 plus 3 is 6. Repeat that. Take the 6 now and multiply it to the 3 of the divisor. So 6 times 3 is positive 18. Put that number right under the coefficient of negative 8. Add. Negative 8 plus 18 is 10. And repeat this again. 10 times 3 is 30. Put the 30 under the 4. Add it, and you have 34. Now your quotient, Okay, so let's recall, if we're just looking at the highest degrees, if you do x cubed divided by x, that power becomes x squared. And so remember that we took the highest degree and divided out 1x. So in order to write your quotient, we're going to annex the variable starting at 1 degree less than your dividend. So we have 1x squared plus 6, 1 less, is x plus 10. And we can get rid of the 1. And your remainder is the number 34. So quotient is x squared plus 6x plus 10, and the remainder is 34. Roman numeral 3, the remainder theorem and the factor theorem. We'll start with the remainder theorem. If a polynomial p of x is divided by x minus c, then the remainder is the value of p of c. Note something very interesting about this. If you write c, p of c is an ordered pair, we find out that the remainder is the corresponding y value for the polynomial evaluated at c. Part A. For the function f of x equals x cubed plus 3x squared minus 8x plus 4, find f of 3. Let's note that we are finding the function value at x equals 3, and we are also finding the remainder of the polynomial when divided by x minus 3. We'll compute f of 3. We'll substitute 3 in every place there is an x, so that'll be 3 cubed plus 3 times where the x was, we put in 3, so 3 squared, minus 8 times 3, plus 4. Let's perform the arithmetic. 3 cubed is 27. 3 times 3 squared, or 3 times 9, is also 27. Minus 8 times 3 is 24, plus 4. We'll just do it sequentially. 27 plus 27 is 54, minus 24, plus 4. And let's see, 24, subtract it from 54 is 30, plus 4. So the function evaluated at 3 is 34. Let's recall that when we did synthetic division for x cubed plus 3x squared minus 8x plus 4 divided by x minus 3, the remainder was 34. Part B. Find the remainder when f of x equals x to the power of 1101 plus 5 times x to the power of 945 minus 45 times x to the power of 456 plus 32 times x to the power of 28 plus 7 when divided by x plus 1. When divided by x plus 1, we set that equal to 0, and we get our divisor constant as x equals -1. You have a couple of choices. You can do polynomial long division. That could take a while. You could also do synthetic division, and that would take almost as long. But with the remainder theorem, we can evaluate the function at -1. So f of -1 is -1 to the power of 1101 plus 5 times -1 to the power of 945 minus 45 times -1 to the power of 456 plus 32 times -1 to the power of 28 plus 7. A negative raised to an odd power is negative. So -1 to an odd power is -1 plus 5 times -1. 945 is an odd power, so that's also going to stay negative, minus a negative raised to an even power makes it positive, so -1 to 456 will be positive 1 plus 32 times negative 1 to 28 is also even, so positive 1 plus 7. This will give us, let's see, negative 1 minus 5 minus 45 plus 32 plus 7, and that'll be equal to negative 6 minus 45, that's negative 51, and then add 32 plus 7 should be negative 12. The ordered pair negative 1, negative 12 gives you a point on the graph of this polynomial function. It also tells you that when divided by x plus 1, you have a remainder of negative 12.
Roman numeral 3, the remainder theorem and the factor theorem. The factor theorem states C is a 0 of P if and only if x minus C is a factor of P of x. Divide P of x equals x cubed plus 2x squared minus 3x minus 10 by x minus 2. The factor theorem lets us compute P of 2, which means we will replace every x in the polynomial with 2. That will give us 2 cubed plus 2 times 2 squared minus 3 times 2 minus 10. Let's do the arithmetic. 2 cubed is 8. 2 times 2 squared, that's also plus 8. Negative 3 times 2 is negative 6, and we still have minus 10. Let's perform that arithmetic. 8 plus 8 is 16. 16 minus 6 is 10. And 10 minus negative 10 gives us 0. Let's get some terms straight. X minus 2 is called a factor. 2 is a 0. It is also called a root. And the ordered pair 2, 0 is an x-intercept. Exercise. Let P of x equal x cubed minus 5x squared minus 2x plus 10. Show that P of 5 equals 0, and use this to factor P of x completely. To show that P of 5 equals 0, let's use synthetic division. I'll begin that by writing the coefficients of the polynomial. For x cubed, that coefficient is 1. We have then negative 5, negative 2, and 10. Our divisor is positive 5. Now let's do the synthetic division. Drop the 1 down. 1 times 5 is 5. Negative 5 plus 5, that sum is 0. 0 times 5 is 0. The sum of negative 2 and 0, that's negative 2. The product of negative 2 and 5, that's negative 10. And the sum of 10 and negative 10 is 0. The remainder of 0 lets us show that x minus 5 is a factor. Now let's expand. X cubed minus 5x squared minus 2x plus 10. Our quotient, the linear factor, is x minus 5. Now what we've got left, we start with the 1, lowering by 1 degree. That'll be x squared minus 0x for that 0, and then minus 2. Now we can continue to factor completely. You've got the x minus 5,
And x squared minus 2 is a difference of squares, but we need to use the square root. So you'll have x minus the square root of 2, x plus the square root of 2. Now that polynomial is factored completely. Let's note, irrational roots or zeros occur in conjugate pairs. That is, if x minus the square root of c is a 0, then so is x plus the square root of c. Exercise. Find a polynomial of degree 6 with zeros, -2, 1, and 4, with multiplicities of 1, 2, and 3, respectively. Let's set up our shell. P of x has 3 distinct zeros. So we'll do an open parentheses x minus, close that parentheses, another one, and one more, x minus. That's for the 3 zeros, the values we were given, -2, 1, and 4. And now looking at the multiplicities, the order is the first one, multiplicity 1, the second one, multiplicity 2, and the last one is multiplicity 3. Clean this up a little bit, and we'll get that the polynomial p of x is equal to x plus 2 times x minus 1 squared times x minus 4 cubed. Let's have a fun think about it problem. Find the constant c so that x minus 4 will divide evenly into 5x squared plus cx minus 12. Divide evenly means a remainder of 0. We need p of 4 to equal 0. Let's put those values into our quadratic. Using p of 4 equals 0, that means we're going to set the function equal to 0 and put in a 4 every place we have an x. So 5 times x squared, we would write that as 5 times 4 squared, plus c times 4 minus 12. Now we need to solve for c. 0 is equal to 5 times 16 times 4c minus 12. 0 is equal to 80 plus 4c minus 12. Let's combine the 80 and -12, so 0 is equal to 80 minus 12. That's 68 plus 4c. We can solve this now. -4c is equal to 68. And dividing by -4 on both sides, c solves to -17. If we let c be -17, x minus 4 will be a factor of 5x squared plus cx minus 12.